We'll finish this section with these word problems. So these are the word problem versions of input-output analysis problems. So let's see how to set up these problems given just a prompt like this. So here it says an economy is based on two sectors, transportation and manufacturing. I'm just going to call those T and M. And it says that the production of $1 worth of transportation requires 10 cents from each sector. And the production of $1 worth of manufacturing requires an input of 40 cents from each sector. So in other words, to produce $1 worth of manufacturing, you're going to need 40 cents of transportation and 40 cents of manufacturing. And then it says find the output for each sector that is needed to satisfy a final demand of $5 billion in transportation and $20 billion in manufacturing. So here we can already set up the demand matrix. The demand matrix is going to require 5 billion in transportation and 20 billion for manufacturing. If you'd like, you can just write 5 and 20 with the understanding that your units are in terms of billions of dollars, but it's also fine to actually write out 5 billion and 20 billion. I would recommend against that though. It's easier to just choose the units, billions of dollars. So we have the matrix D. Next, what I want to talk about is how to set up the matrix M. So M is called the technology matrix or the input-output matrix, but the idea here is relatively simple. Each column is going to represent the costs for producing one unit, and sometimes the units are measured in dollars, so I'll say 1 unit or $1 of each of these industries. So we'll have the costs for producing 1 unit of transportation and then the costs for producing 1 unit of manufacturing. The most common mistake in these problems is to forget that this is supposed to be the column meaning and not the row meaning. So for this first column, we're going to set it up as the costs for producing a unit of transportation. Now the rows are also going to correspond to the same industries, transportation and manufacturing. And it is important that you choose the same ordering for your rows and your columns. So if your rows are transportation and then manufacturing, your columns should also be transportation and then manufacturing. But here we'll get a 2x2 matrix. But again, the important thing is that the column is supposed to represent the costs for producing that unit of each of these industries. So for this first column, I want to record in each of these entries the cost for producing $1 of transportation. And from the prompt, it says that the $1 worth of transportation requires 10 cents from each sector. So that's how I would find the first column. You can interpret this as saying that the production of 1 unit or $1 of transportation requires 10 cents transportation and 10 cents of manufacturing. And then we're going to do the same thing for M. So for the second column, we want to know the cost for producing 1 unit or $1 of manufacturing, and that looks like 40 cents from each sector. So this top right entry says that to manufacture 1 unit of manufacturing, it's going to take 40 cents of transportation, and then the bottom right says it will also take 40 cents of manufacturing. So just remember that you're setting up the columns this way and not the rows. So it's easy to take the transpose of this matrix and get a little bit confused, but in order for this model to work, you need to build each of the columns as the cost for producing that 1 unit or $1 for each of these sectors. Okay, so that's the matrix M, but we're not done because what we need is the matrix X. And remember what we had is this equation that the production matrix is equal to I minus M inverse times D. So this would be the 2x2 identity matrix, because M is a 2x2 matrix. Minus M, and then we're going to take the inverse after taking that difference. And then we're going to multiply by D, which was 520. Now, whenever you're computing this, it is important that you first compute the difference and then invert. You don't want to invert the matrix M, you want to invert the matrix I minus M. So first compute the thing on the inside of the parentheses here. This looks like it would be a 0.9, negative 0.4, negative 0.1, and 0.6. That's what we want to invert. And then we're going to multiply by the matrix 520. Now, for the sake of time, I'm just going to tell you what this inverse ends up being, but we could compute it by hand like we did in the previous exercise. So this will end up being a 1.2, a 0.8, a 0.2, and a 1.8. I'm not able to do that mentally. I'm just looking at some other notes. And then we have the matrix 520 that we want to multiply by. And now to finish this computation, we can compute the resulting 2 by 1 matrix. So 1.2 times 5 would be 6, plus 0.8 times 20 would be a plus 16. So 6 plus 16 is a 22. And then 0.2 times 5 is 1, plus 1.8 times 20 would be a 36. So 36 plus 1 is a 37. So this would be the matrix X, which tells us the production. And to give sort of a final answer here, what we should say is, remember that our units were in terms of billions of dollars. So we should say that the production should be 22 billion in transportation, and 37 billion in manufacturing. Okay, so we can go back and interpret this in terms of the original prompt, but that's the total amount of output in each sector that's required to meet this final market demand. Or in other words, to have that much excess once you have used the internal costs. So a good sanity check in these problems is just to check that your final answer here is actually in excess of the demand. So notice that our demands were 5 and 20, and the total production that we see that's required is 22 and 37. So it's true that our production exceeds the demand, and that should always be true, assuming you set up the problem correctly. So that gives you a way of sort of checking your answer, or at least checking that your answer is plausible. Okay, so in example 5, we're going to do the same thing. This time we have a 3 by 3 case. In this problem, it says you do not need to compute the matrix inverse. So here I just want us to set up the problem so that X is equal to some matrix inverse times some other matrix. So I do want us to find these two matrices, but I don't want us to actually compute the inverse, because computing the inverse of a 3 by 3 decimal matrix by hand was just kind of a nightmare. So I'm going to avoid doing that for now. Instead, we're just going to set up the general problem. And the setup will go like this. So here it says a large energy company is producing electricity, natural gas, and oil. I'm going to abbreviate those as E, G, and O, just to keep those in order. And just to switch things up, let's go for setting up the technology matrix first. So I'll keep these in the order that they appear in the prompt. So we'll have electricity, gas, and oil, and then electricity, gas, and oil. And remember that in this matrix, each column is supposed to represent the total costs for producing 1 unit of the column index here. So if we look at this first sentence, or I guess the second sentence in the prompt, it says to produce $1 worth of electricity requires inputs of 30 cents of electricity. So that would be a 0.3 in this entry. 10 cents of natural gas. So that would be a 0.1 in the G row. And then 20 cents of oil. And then the next sentence tells us the same costs apply for a dollar's worth of natural gas. So that would be a 0.3, a 0.1, a 0.2. And then lastly, it says the production of a dollar's worth of oil requires inputs of 10 cents from each sector. So that would be 10 cents of electricity, 10 cents gas, 10 cents oil. So this is the technology matrix, or the input-output matrix in this problem. And the last part says that we want to write an expression for the output from each sector that's required to satisfy a final demand of 25 billion in electricity, 15 billion in gas, and 20 billion in oil. So in this case, we didn't have to be super careful. In all of these sentences, electricity came first, and then gas, and then oil. But it's possible that these might be permuted in some way, so you do have to be a little bit careful that you're always using the same ordering for your industries. Here, the ordering that I chose was electricity, then gas, then oil. So if any of these are mixed up in the prompt, it's your job to reorder them so that everything is in the correct column or correct row. Okay, so that gives us our technology matrix and our demand matrix. And now we have enough information to find the production matrix X. Remember, that's I minus M inverse times D. So that would be the 3x3 identity matrix minus the matrix M and this is the matrix that we would compute the inverse of, but we're told in the prompt that we don't have to worry about it, thankfully. And now we have the matrix D, which is 25, 15, 20. Okay, so if I ever give you a prompt like this that just says you don't have to compute the inverse, all that I expect you to do to finish out the problem is to just compute this difference on the inside of the parentheses. So we'll just compute this underlined thing, and then otherwise we'll leave the expression as it is. So notice that in most of these entries, we're taking a 0 and then subtracting the entry from M. So in all of these off-diagonal entries, we're just going to get the negation of the entry that lived in M. So we'll get all of this stuff. And then for the diagonal entries, we're just taking 1 minus the entry in M. So this would be a 0.7, this would be a 0.9, and this will be a 0.9 as well. So this is I minus M, but in the formula we need I minus M inverse. So this would be I minus M inverse times the matrix D. And if we were to proceed with this problem, we would compute the inverse over on some scratch paper and then finish computing this product. So you can't just multiply right now. You have to first address the inverse, so compute the inverse of this left matrix, and then you could finish multiplying. But just to make things a little bit nicer, we're not going to worry about computing this inverse. Instead, we'll just leave our answer in this form. So unfortunately, leaving the answer in this form doesn't give us much room for interpretation because we don't actually know what the values will be for this production matrix, but it does give us a convenient way of producing the production matrix if we did need to compute it later. Okay, so that's it for the applications problems. That's also the last thing that we have in this entire unit. So remember that your next exam will be next week. I'll be sending out some information about that soon. My basic plan is that we will have online exams that you will take using your own paper. So you'll write down all of the problems in your work on scratch paper, and then I'll have you upload those in the same way that I'll have you upload the homework. And I'll give you more information about that